Hello, everyone, and welcome to the meetup about microservices decomposition strategies that work. So, this meetup isn't about overviewing the many strategies you can find um, summarized in papers, books, and so on. Uh, this meetup will focus on those strategies that I believe will usually work. And we shall also add some context uh, regarding the AI, the revolution we go through. Things change, and so are the best practices. So we will talk about that as well. So my name is Chaim Michael. I am a lecturer in the university for more than 25 years. I teach usually advanced topics, elective courses in computer science. Before that, I was a lecturer for courses in microeconomics. In addition, I also have my own private company where I deliver premium training services to software developers and business briefings and seminars to managers. So, Um, more details about me. I live in Tel Aviv. As I said, I have my own company. In the past, there were employees, developers, so on. During the years, it was shrinked, and after COVID-19, it was shrinked even more. And eventually, the main activity was premium professional training services. Now, when AI came out, possibilities emerged, and my passion to build, uh, well, I can't describe it. I find it difficult to pick the right words, but deep inside of me, I have a passion to build. So I started building ventures, various ventures, and all of them, each one of them is kind of a separated company. In my private registered company is Intel Technologies, and this is a small diagram showing you the ventures. So I have Zindrex, Cyber, Engager, you will see it in action. Jacado, I'm bringing back to life casual games I developed in the past in my company 25 years ago. Prompo to organize your context you have with AI agents, chatbots, and so on, and Nana events for events discovery. But the premium training services, business briefing is everything that described in Life Michael. And as I said, my passion is teaching lifelong learning. I continuously learn, evolve, and I do it because I enjoy it. And my academic background is actually economics and accounting and MBA information system from Tel Aviv University. And today I teach, well, I teach in many institutions, but today it is Bar-Ilan University, Ben-Gurion University, Rajam University. It starts next semester, and HIT as well, where I teach for many years. But in the past, I teach also in other places. And these are the domains in computer science I find most interesting, especially AI-driven development, AI agents, spec-driven development. This is the main domain where I focus. I wrote books in economics, books in computer science, spec-driven development. If you are into it, send me a message, email, LinkedIn. I will send you the PDF. Highly recommended. I'm also a Career Ambassador by AWS and also AWS Community Builder and a few other titles. Anyway, I strongly recommend you to check it out. I'm using Kiro when developing my ventures. It's amazing. AI agents actually do everything. Okay, I also develop courses in Hebrew, courses in English, lots of courses on Udemy, and passion for build. I've already told you the story, and let's start. So, first of all, I want you all to be on the same page because I understand that some of you don't have real experience with developing microservices. So let me try to put you all on the same page. I also recommend those that haven't attended the previous meetup about uh, monolith compared with microservices to catch up. You can find the video and the slides on my blog. My blog, you saw the link before. There is a page with all slides. There is a page where I list all talks I deliver, and each talk has a link to the video and the slides. So you catch up. Actually, this is the second meetup out of a series of meetups that focus on microservices architecture, mainly design patterns, but not only design patterns. So stay tuned. If this domain is interesting for you, just make sure that you join the next meetup about this specific domain. In between those meetups, I will deliver other meetups about other topics. Check the meetup group at meetup.com/lifemichael. So now let's try to be on the same page, all of us. So first of all, you need to understand we're talking about developing the code that is running on the server side. It can be a code developed in Java, JavaScript, Python, whatever. It's not important. The programming language is not important. And so the framework you are using, there might be differences if you develop server-side that works asynchronously because you chose Node.js or FastAPI, or there are also great libraries in Kotlin. So in that case, things will look a bit different, but this is only when you start looking at the lower level. But when you are on the higher abstract level, looking at the entire system, it's not important which programming language you are using, which framework, which library. This is not what matters. What matters is the architecture, is the components within, and the way they interact with each other. And when talking about microservices, we simply talk about a server side that instead of being one application running on one server, we have multiple applications. Each application is running on a separated server, and it works as a service, as a microservice, a small service for something very specific. Now, usually it is a RESTful web service, so it takes a request with some data, and it returns data, usually in the JSON format. But it doesn't have to be the JSON format. It can be also something else. It can be XML. It can be an image. And also the use of HTTP. It doesn't have to be HTTP. It is usually HTTP because it is simple, but it doesn't have to be HTTP. There are other options. Maybe we will cover them in one of the next meetups. Anyway, it's not that microservices is always the best option. You need to some judgment about that. I can give you, for example, Engager. You have just tried it. I don't have, for now, microservices on the server side. I don't want that complexity. This service, this platform is still alpha. We're still doing the first steps. There are still features to add and bugs to fix. But at some point, hopefully, it will become popular. Maybe there will be a place to think about the option to split the one application that is currently running on the server side to multiple applications. Maybe, maybe not. It all depends on what comes next and how successful that venture will be. And I don't know how successful it will be. So for now, it is good for me having a monolith. The development was simpler, deployment was faster. This was the choice. But you see, when you develop a business, when you have a system and there is a server side, there are cases where splitting that monolith into microservices makes sense. We talked about the many advantages we have when splitting a monolith to microservices. You see, there are advantages and disadvantages in every option. It's not that there is a silver bullet, something specific. You do it, you succeed. No, it doesn't work that way. You need to be aware of the advantages and the disadvantages of each and every option. And actually, this is in my opinion, one of the most important capabilities every builder should have these days, that we have AI that actually does the coding. We need to be on a higher level, deciding, choosing, and to be there, we need to be aware of the possibilities. So this is one of the reasons why I have that urge to learn so much and so fast, and I put so many hours during the week on that. So what are the real reasons to take a monolith and decompose it, break it into microservices? It isn't because we want to say we have microservices. No, it doesn't work that way. There are advantages that probably relevant in our case, and for that reason, we want to decompose. And usually, if you have a monolith, if you develop a monolith, you better think in advance when it comes to decomposing how you intend to decompose. So the real reasons for decomposing, and I will start from the last one, is the possibility to scale just the specific microservice or microservices, which are actually portion or only part of the system. You see, if you have huge traffic, huge number of users, imagine Engager. I have a huge number of users. It doesn't mean that I should scale the entire system. Maybe there is a bottleneck in specific part of the system. So when I decompose the server side into multiple parts, multiple microservices, I can scale, I can put more money into hardware or whatever in those microservices that need to be scaled, not all of them. So this is very important, and usually this is the main factor that push us in the direction of moving to microservices. Now, there is also the advantage of having a team dedicated for each and every microservice. Now, when thinking about teams, now that we no longer code, well, it's not exactly teams, maybe a human that is responsible for a specific microservice or more than one. And when you have that authority, when you have that, let's talk about teams. A team of developers responsible for a specific microservice, it means that they can take their decisions independently and evolve that microservice as long as they maintain the API they should provide to the other microservices, of course. But for the other microservices, that microservice is actually kind of a black box. So those developers that are responsible for that microservice, they have the ability to decide how to move forward, how to implement which design patterns, maybe even switch to another programming language. This is possible. Another advantage when doing that change and move to microservices is the ability to deploy safely. When you have instead of one monolith application, you have multiple microservices, you can deploy each microservice safely, separately from all others. So if, for instance, we implement something, a change in the way the code is running, and we need to deploy that change, it is just about deploying that specific microservice. We don't need to deploy the entire monolith. So it is simpler, which leads to changing the service, what the code is doing faster. We can introduce changes much faster when we have multiple microservices instead of one monolith. Because when you have multiple microservices, each microservice can be maintained and changed as respond to changes in the market or in the domain very fast compared with the case where we have a monolith. So these are usually the real reasons to decompose. Now, how are we going to decompose? How are we going to break the monolith? So the number one mistake is to decompose based on technical aspects, meaning we have, say, MongoDB, let's do a microservice from that MongoDB. This would be usually a mistake. It would be best to decompose based on the business. So we can have a microservice handling customers. We have a microservice for handling the billing. We have a microservice handling the shipping and so on. That separation will make it simpler to maintain in the long run, especially that now we move from coding in programming language to coding in English. I don't know if you are already feel that change. Me, on my end, I no longer code. I write specs in English. So if you understand, let's say, that specific billing domain, and you write the proper specs, eventually you get what you wanted to get. So splitting the monolith based on the business operation, decompose the monolith to business separated microservices that each and every one is actually responsible for a specific business capability. That is this approach is aligned with the change we experience these days, moving from writing code to writing specs. So you have someone that is specialized in accounting, he will write the specs for the billing microservice. So usually this approach is the approach that works. Now, it doesn't end with that. If you took the decision to have microservices, pay attention. We want microservices with low coupling with each other. So we can, only when you have multiple microservices and there is a very low coupling between each and every one of them, it would be simpler to take a specific microservice and put something else instead. It would be simpler, simply like that. Developing from scratch, using another programming language, using another technology, a specific microservice, that works if we have low coupling between those microservices. Now, cohesion is about what happens in the microservice itself. Inside the service, if everything is tied together, well, that means that there is no place to break that microservice into smaller ones. But if we don't have cohesion inside the microservice, then we might better consider the option. Maybe there is a place to break that microservice even further. So eventually, what we want to achieve is multiple microservices that each and every one of them has high cohesion inside of it, and all of those microservices maintain low coupling with each other. This is the target. Go in that direction, you will be on the safe side. Now, the data. This is one of the biggest mistakes. You split the monolith into multiple microservices, and those microservices, they access the same database. Or let's say we have 2 or 3 microservices using the same database. Well, sometimes maybe there is no alternative. But you see, the optimal situation, the best approach would be having each and every microservice with its own data. The service owned data. Each service will own its own data. And if there is a need for data that belongs to another service, let's maintain a replication, and let's make sure that it is continuously updated. This way, there will be less interference between the various microservices that share the same data. We don't want a shared database. When we add a monolith, okay, that's fine. But now that we break that monolith into separate microservices, it would be better that every microservice will have its own data. And if it needs data that belongs to another service, let's have that service having a replica of that data. And through event-driven architecture, we can make sure that in the long run, when the system is up and running, that replica of data will be updated when needed. Now, when we say independent deployment, what does it mean? Well, we should look for microservices that each and every one of them can be independently deployed, which means we can deploy it without caring about the others. We can test it independently. We can roll back if we want. We can monitor it without any interference from the other microservices. We can have one single team responsible for that microservice. If we have all that, then we are in the right direction. But if any of these questions, the answer is no, then maybe we should avoid setting up that specific microservice, because it will lead eventually to some problems later on. So independent deployment is highly important to have for each and every microservice we plan to develop. Now, I placed a link to an article by Martin Fowler, where it is. Here it is, the link. And what is that strangler fig? Well, this is a plant that grows on a big tree, and then the roots are growing to the ground. Eventually, they stick roots in the ground, and eventually, those roots, which is actually a plant, wraps the entire tree, kill it, and take its place. Well, this is the approach that for many years was very common for doing that transition from a monolith to microservices. We have the existing monolith, and then we find a part of that that we can take out as a separate service, or maybe create a new service, and we repeat that cycle while keeping the legacy up and running till eventually we get multiple microservices that actually replace that monolith we add. Well, this was very common for many years. Now, if you ask me, now that we can generate code so fast, uh, so accurately, at least this is my experience, I'm not sure that this pattern is still relevant. Well, I put a question mark on that. It depends on the organization. If the organization has already shifted from the old way of the software development to the new one in which AI agents are doing everything, maybe it would be smarter to develop the entire system as a new one properly using AI agents, and then develop a transition plan from the old system to the new one. I think there are cases that approach would be better. There are other cases where maybe the system is too big and maybe the organization still doesn't have that professional capability, that maybe that old way of doing things, the strangler fig migration pattern, will be more suitable. So I don't have a silver bullet to give you. I just say, be open mind, think about the possibilities, because maybe that strangler fig migration pattern, named after this tree, that plant, maybe is no longer relevant in that specific case you examine. Now, usually the composition will look like this. You will discover part of the system you want to extract, you slice it, validate, and then you have a microservice, and you repeat that till the entire monolith becomes multiple microservices. um, Okay, anti-patterns to avoid. Well, first, a microservice, which is actually just slicing out the user interface or a specific small data service, something that is not independent. This is something that was sliced out because of technical reasons. I call it layer services. For instance, you have a system and part of it use MongoDB, and then you take that part of using the MongoDB and take it away as a microservice only. Well, when doing so, you no longer split the monolith um, to microservices based on the business flow. You base your decision on technical reasons, and that eventually leads to technical debt, actually, in the long run. So this is one anti-pattern to avoid. Another, you split a monolith into microservices that keep using the same database. This is the shared database anti-pattern. Well, at start, maybe it works, but at some point, there will be difficulties and bugs and problems. Remember what I told you before? The best strategy is having each microservice with its own data. Don't have data shared by more than one microservice. And if a microservice needs data that belongs to another microservice, maintain a replica and use event-driven architecture to keep it updated. Another anti-pattern, too many microservices, nano-services. There is a system, and then a decision is taken. Let's split it into a huge number of microservices. Huge number of microservices. This is also something that we need to manage, coordinate. It's operational noise. Too many microservices. Remember an Engager? In Engager, I have monolith. I haven't even split it to separated two services, one for the teacher, one for the student. No, one monolith because this is fine for the moment. Splitting a monolith into A huge number of tiny services, this is noise. You don't want that. Now, another anti-pattern, when you have separated microservice, and when something happens on one service, in a synchronous way, something else happens on another service, in a synchronous way, something on another service. This chain, this blocking calls, it's a recipe for trouble. So first, my recommendation, event-driven architecture. Don't mess, or at least make an effort to avoid synchronous calls, because then you might get synchronous chains. And when you have synchronous chains, you might have too many blocking calls, and then you have trouble. And another anti-pattern, the last one, team mismatch. Well, you decide about splitting the monolith to microservices. You take decisions regarding the teams, but it's not clear. And it's not that every microservice has its own team that is responsible for it. When that happens, we get friction, we get problems, trouble to coordinate, we get bottlenecks. You must have a very clear picture. Each microservice, which team is responsible for that microservice. Each microservice should have a team that is responsible for it. If you don't have it, or it is impossible or difficult to achieve, it leads to problems. So the takeaway, and we finish. Think about the business capabilities when you split the monolith into microservices. Try to have each and every microservice as its own data. Don't try to avoid cases in which multiple microservices access the same data. You don't want that. The team ownership, it should be very clear, each microservice, which team is responsible for it. Otherwise, trouble will come. The integration between the microservices should be very clear. What are the contracts between the microservices? What is the API each microservice provides? If that is not clear, problem will come. Noise will emerge. Now, you should always check whether each and every microservice, we can deploy it independently, test it independently, roll back independently, monitor independently. You can't allow having microservices that don't enjoy that. Each microservice it should be possible to deploy, test, rollback, and monitor independently. Otherwise, the team responsible for that specific microservice that doesn't provide us with these capabilities will face difficulties. And eventually, we get noise, human friction, problems. And then you also need to think about the migration path from today architecture to the new one that is based on microservices. So as I said, maybe this approach, this is an article for 2024, is the best approach for your case. Maybe not. It all depends on many factors, including how well the transition in that organization took place from the old world where developers code to the new one in which we use specs and we have less developers, and most of development it happens through AI agents. So actually it changed from one organization to another. You can find on one end one human developing lots of systems, as in my case, and on the other end you can still find companies with a huge number of developers, lots of friction, and struggling to move forward to a new reality, a new state in which we don't have so many developers and most of the work is done by AI agents. So that was it. Here you can find, you will have that slides, you can have links to the for online conferences. People without job, students, juniors, just send me an email. I will send you a free pass. And if you don't belong to those groups, the fee is very low. It's not about money. Those conferences, I do it for many years. It's a community-based conferences. Now we have those four newsletters every month. Register for free and enjoy up to date. I get lots of newspapers. I mean, from lots of sources for each and these four domains, and I simply find the most important items and put them together. And now these are the initiatives, the ventures I ran. QR code for my LinkedIn page. I will be very glad to be in contact. And the Meetup group. If you joined to this Meetup through Eventbrite, or there is also another site, I forgot the name. I recommend to join the Meetup group on Meetup because this is where I run the meetups for now. There is that website, its name is Luma. So I publish the events on Luma as well, but this is the main website. So if you want to be updated on everything, join the Meetup group on Meetup. Now let's get back to the engager, and after that, few questions. So the first question, and we will have a podium where we see the winners. Would it be correct, or let's say it differently, when splitting a monolith to microservices, it would be best having each microservice with its own data without, or with its own database or data, okay? It would be best to avoid a scenario where two or more services use the same database. Is that correct? So go into Engager. I don't mark the answer. I will specify later. I create a question, and now you have 30 seconds to answer. We're talking about that. Just answer, is that correct or not? So, what do you say? What should I, what is the answer? Do you want to say or leave that to me? You can speak if you want. Okay, this is correct. We will do our best to have every microservice having its own database. We will make an effort to avoid scenarios where we have two or more services using the same database. So this is correct. Now, another question. Let's, yes, no question. We should avoid a huge number of micro services, what is called services, nano services, when there is no need, no real need in that. This is a well-known anti-pattern. Is it correct? So you have 30 seconds. Should we avoid a huge number of microservices, nanoservices, where there is no real need in that? This is a well-known anti-pattern. Is it correct? So we overview those anti-patterns. Don't answer in the chat. No. Sava, don't reveal the answer. You should answer in your engager, and eventually we will have a podium. So should we avoid that? Is that an anti-pattern? Yes, it is an anti-pattern. Too many microservices when there is no real need in that, just maybe to show off we know microservices. This is not a recommended approach. This is actually an anti-pattern. There are companies doing that mistakes. Don't be in a rush to develop microservices just to show off, I know about microservices, look what a great system I developed. Be aware there is a cost involved with managing so many microservices, and maybe that cost is not needed. We can avoid it. There is no need in that. So this is correct. Now, another question. Is it correct that when splitting a monolith into microservices, we cannot have more than three microservices? So, this is the question. So, is it correct that we cannot have more than three microservices? What do you think? Is it bad to have more than three microservices, or is it impossible to have more than three microservices? I've never mentioned the number three during our talk, actually, and now I can answer. There is no such thing. We can see great server-sides microservices architecture with more than three microservices. This is nonsense. There is no such thing. Maximum number of microservices. It all depends in that specific case, that specific business. So it's not correct. You can have more. It's not correct. Save the correct answer. And now let's end the lesson and see the podium. So what do we have? Q, 3 out of 3. Heva, 3 out of 3. Major, 3 out of 3. This is great.